this section, we're going to take a look at graphing linear equations in slope-intercept form. Now, a few lessons ago, we talked about graphing linear equations using an XY table. And just to refresh your memory, whenever we have a linear equation, we can graph it using an XY table by following the following steps. So our first step is we're going to pick 5 input values, 5x values here. And we want to pick smart values. So since our equation is y equals 1/2 x plus 3, we want to pick numbers that when we multiply them by 1/2, they're going to come out nice and neat. So I'm going to pick -4, -2, 0, 2, and 4. And it's also good to pick some positives, some negatives, and 0 is always a nice easy number to plug in. Okay, from there, we take our inputs one at a time and we're going to plug them in for x. So if we plug -4 in for x, it's 1/2 times -4 plus 3. 1/2 of -4, well, 1/2 of 4 is 2, and a negative times a negative makes it a positive. So 1/2, or -1/2 times -4 is positive 2 plus 3. And 2 plus 3 is 5. So when we plug in -4, the input -4, we get the output 5. Okay, if we plug in the input -2, y is equal to -1/2 times -2 plus 3. Well, 1/2 of 2 is 1, and a negative times a negative makes it a positive 1. So we're looking at 1 plus 3, and 1 plus 3 is 4. So when we plug in -2, we get the output 4. And I'm going to go ahead and have to erase a little bit here to give me a little bit more room to work. Let's go ahead now and plug in 0 in for x. So when we plug in 0, we get -1/2 times 0 plus 3. Well, -1/2 times 0 is 0. So we're looking at y is equal to 0 plus 3, and 0 plus 3 is 3. So when we plug in 0, we get the output 3. Okay. If we plug in 2 for x, it's -1/2 times 2 plus 3. -1/2 times 2 is going to be a -1. And we're looking at -1 plus 3, and -1 plus 3 is positive 2. So when we plug in 2, we get 2 as our output. And then the last one we're going to plug in here is 4. And I'm going to do a little erasing again so we can plug in 4. If we plug in 4 into our equation for x, y is equal to 1/2 times 4 plus 3. -1/2 times 4, so 1/2 of 4 is 2, and a negative times a positive makes it a -2. So we're doing -2 plus 3, and -2 plus 3 is 1. So if we plug 4 into our equation, we get the output 1. And now all of these points, all of these pairs in our table are points on our graph. So we start by graphing the point -4, 5. And then we do the point -2, -4, 5 should be up here. So -4, positive 5 is up here. -2, 4. And we're at 0, 3. The next point is 2, 2, so right 2, up 2. And the last point is over 4, up 1. And we plot those points and we get a straight line, and if we draw a line through those points, put arrows on the end, there's the graph of the linear equation y equals -1/2 x plus 3. So that's the way we had previously talked about graphing these. And today we're actually going to show you a little bit of a shortcut for graphing linear equations. So let me scroll down here and let's talk about it. All the equations that we've been working with thus far are in slope-intercept form. And slope-intercept form is in the form y equals mx plus b, where that m number, that number that's attached to x, represents our slope, or how steep our line's going to be, and b represents what we call the y-intercept. And we'll talk about what the y-intercept means here. But basically the y-intercept is where our graph crosses our y-axis. So knowing this formula, y equals mx plus b, where m is our slope and b is our y-intercept, it becomes really easy, a lot less work to graph these linear equations. And we'll show you how right here. So in number 2, number 3, it says, identify the slope and y-intercept of the equation, then graph the linear equation using the slope and y-intercept. So our first step here is to, we want to identify our m and our b. So in number 2, we have the equation y equals negative 1/2 x plus 3. Okay. And our m, our slope, m is that variable we use for slope, is the number that's attached to x. So that's right here, negative 1/2. And our b, our y-intercept, is positive 3. So we have a slope of negative 1/2. We have a y-intercept of positive 3. Now when we go to graph this, our first step here is going to be to graph our y-intercept. And our y-intercept is always on the y-axis. So the first point that we graph on all these linear equations is going to be on the y-axis right here, this vertical axis. Okay, so let's start by graphing positive 3 on the y-axis. So here's our y-axis. There is positive 3 on the y-axis. There is the first point on our line. Okay. After we've plotted that point, we are then going to go over to our slope to help us find the other points. Okay, so let's talk about this slope. Our slope is equal to negative 1/2. So whenever we have a negative slope, okay, we are going to, I would say it's best to put this negative sign up with our top, with our numerator. Okay, the negative sign only goes to one of these numbers. And in our case, we're always going to move it to the top. So I'm going to rewrite that slope as negative 1/2. And that's going to help us find the rest of our points. Now, if you remember, slope is rise over run. So this negative 1 represents our rise, and this positive 2 represents our run. And here's how that works. So starting at the point that we have already made, our y-intercept, we are going to do a rise of negative 1. So that means we are going to go down 1 and then a run of 2. And positive 2 run means we're going to the right. So we're going down 1, right 2, and there's our next point. And then we can just continue with that same pattern. Down 1, right 2. Down 1, right 2. And you can see that line starting to develop here. Well, if we want to then go ahead and make some points the other way, now that we've gone to the right, we can kind of fill in the pattern. Instead of going down 1 and right 2, if we want to keep with that pattern, we can go up 1 and left 2. And that still gives us the same slope. It's just a way of we can fill in the rest of those points there on that line. Once we've made about 4 or 5 points, we can go ahead and connect them and draw an arrow through them. And there is the graph of the line y equals negative 1/2 x plus 3, which is exactly like the graph that we drew up top here, just significantly less work. Okay, so this is a challenging skill, but it's one worth mastering because it saves you so much time when you are graphing these lines. Okay, let's scroll over here to number 3 and let's take a look at it. First step, identify the slope and the y-intercept. So our slope is the number that is attached to x. So our slope m is equal to 3/2, and our y-intercept b is equal to negative 4. That negative sign goes with the 4. So b, or what we call the y-intercept, is equal to negative 4. Okay, so when we graph this, our first point is always on the y-axis. So we are graphing that point right there on the y-axis. Where's negative 4 on our y-axis? And that's right here. Okay. And after we've done that, then our slope does the rest of the work. So we have a slope of 3, positive 3 over positive 2. So the positive 3 is our rise. Wrote that wrong. Positive 3 is our rise, and the positive 2 is our run. Okay. What does a rise of positive 3 means? It means we are going up 3. So we're going to go up 3. And a run of positive 2 means we are going right 2. Okay, that just goes back to when we talked about slope, drawing those arrows in. I would say it might be helpful to go back and draw those arrows in to help you with plotting the rest of these points here. So Now that we have identified our rise and our run, we go back to our initial point right here, and we're going to start there and go up 3, all right? Go up 3 and then right 2. So count 1, 2, 3 up, right 2. There's our next point. 1, 2, 3, right 2. There's our next point. And then we just continue up 1, 2, 3, right 1, 2. There's our next point. And then we continue up 1, 2, 3, right 2. And there's our next point. And we get this nice straight line. And if we draw a line through it and put arrows on the end of that line, there's the graph of the linear equation, y equals 3/2 x minus 4. Okay, let's take a look at some other examples here on the back side. All right, in number 7, we have the equation y equals 2x plus 1. So let's identify our slope. Our slope, m, is equal to 2. It's that number that's attached to x. And our y-intercept, b, is equal to positive 1 here. Okay. So we always start with our y-intercept, and our first point on our graph is always on the y-axis. That's this axis right here. So where is positive 1 on the y-axis? That is right there. Okay. From there, we use our slope to find the rest of the points. So our slope, m, is equal to 2. Well, anytime we have a slope that's just an integer like that, let's turn it to a fraction by putting it over 1. Sorry, 2 over 1. 2 can be rewritten as a fraction, 2 over 1. And the reason I like to do this is now we know that our rise and our run. So we are going to have a rise of 2 and a run of 1. And let's go ahead and turn those into arrows. Positive 2 rise means we're going up 2. And a positive 1 run means we are going right 1. So from our y-intercept, we're going to count up 2 and right 1, and that'll be our next point. So we go up 1, 2, right 1, there's our next point. Up 1, 2, right 1, there's our next point. Okay, we can continue with that pattern. You should be able to see if we continue with this pattern going left, instead of going up and right, we can go down and left. So we go down 2, left 1. Down 2, left 1, and we still get that same pattern, that same slope. Okay, draw an arrow through those two, or through all those points. Draw a line through all those points, put arrows on the end. There's the graph of y equals 2x plus 1. So you can really see how knowing this skill is just making these problems go faster and faster. Okay, let's look at a couple more variations that might pop up here. Number 8, y equals negative x plus 1. Our first step is to identify our slope. So our slope is the number that is attached to x. And remember, a negative x is just like having a negative 1x. So this equation is really like negative 1x plus 1. So our slope is negative 1. And our y-intercept is positive 1. Okay. Let's go ahead and start by graphing our y-intercept here. Our first point is always, always, always on the y-axis. So we are finding 1 on the y-axis and plotting that point. Okay. Then from there we go to our slope to help us find the other points. So let's write our slope down here. It's negative 1. And we need, remember, for slope we need a rise and a run. So we want to turn this into a fraction by writing it over 1. So our slope is negative 1 over 1. Which is equal to negative 1, but it's just better to see when we have a rise here and a run. Okay. So negative 1 rise means we're going down 1. Remember, a negative is going down with our rise, and a positive 1 run means we're going right 1. So from the first point, from this point that we've already graphed, we are going to go down 1, right 1 to find our next point. So let's go down 1, right 1, and down 1, right 1, and down 1, right 1. And if we continue with that pattern, okay, we get a straight line here. Instead of going down and right, if we want to continue that pattern to the left, we can go up 1, left 1, up 1, left 1, up 1, left 1, and we still get that same slope. Okay. Draw a line through it, put some arrows on the end. There is the graph of the equation y equals negative x plus 1. Okay, the important part here is to note that if you ever see a negative x, it's like a negative 1x. So negative x has a slope of negative 1. How about number 9 here? Let's identify our slope and intercept. Okay, it's oftentimes that's the most difficult part. So for number 9, y equals negative 1/3 x. Our slope is the number that's attached to x. That's a negative 1/3. And our intercept, okay, is this number out here. Well, there's nothing out here. So when there's nothing out here, it's like having a plus 0 there, but they don't write that because it doesn't do any good to write plus 0. So whenever there's nothing out here, our intercept is 0. Okay, so let's go ahead and graph this now. So we always start with our y-intercept. So we're going to graph on the y-axis. Where is 0 on our y-axis here? Well, here's our y-axis. There's 0. There's our first point. Okay, now let's take a look at our slope. M is equal to negative 1/3. Now, like I had mentioned earlier, when we have a negative slope, the negative either goes to the numerator or denominator. I say it's best to always just have that negative sign go in the numerator. Just get in the habit. It only goes in the numerator for our purposes here. Okay, let's go ahead and now, so that means we have a rise of -1 and a run of +3. And if we go ahead now and draw those arrows, a rise of -1, remember rise tells us how much we're going up and down. So a negative would mean we are going down 1. A run tells us how much we're going left or right. So a positive run, positive on our number line is to the right. So a +3 means we're going right 3. All right, so starting from our y-intercept, the point that we just plotted, we are going to go down 1 and right 3 to find our next point. So we go down 1, right 1, 2, 3. There's our next point. And we can continue with that pattern. Down 1, right 1, 2, 3. There's our next point. Okay, instead of going down at 1 and right 3, we can go up 1 and left 3, and we get that same pattern there. Up 1, left 3, and we get that same pattern. Go ahead and connect them. Use a straight edge or ruler to connect those. It's hard to do it on a touch screen here, but you should always be using a straight edge on your paper there. So draw a line through them, put arrows on the end because that line keeps going forever and ever and ever. And there we have the graph of y equals -1/3 x. Okay. The new thing we did throw in on this problem is to remember if there's nothing out here on the end, okay, that y-intercept is 0. Okay, a couple more examples, couple more variations that you might see. Number 10, y is equal to x. So let's start by graphing or figuring out our slope and our y-intercept. So our m, our slope is that number that's attached to x. What number is in front of x here? Well, even though it's not written, we understand that that number is 1.
Mr. Simmons, please dial extension 101.
Now let's take a look at our y-intercept. Our y-intercept is this number out here, and like we had just talked about, if there's nothing out there, it's like having a +0. We just don't write it. Our y-intercept is going to be 0. So we're looking at a line with a slope of 1 and an intercept of 0. Okay, let's go ahead and graph that. So if our y-intercept is 0, that means our first point we're plotting is 0 on the y-axis. Every single first point we plot today is going to be right on that y-axis. Okay, from there we use our slope. So if our slope is equal to 1, we want to turn that into a fraction because we need a rise over run. So we can turn that into a fraction by putting it over 1. So we are looking at a rise of 1 and a run of 1. And if we were to draw that in arrows, a rise of +1 means we're going up 1. A run of +1 means we're going right 1. So from our point, from our starting y-intercept, we're going to go up 1, right 1 to find our next point. So up 1, right 1. There's our next point. We just continue with that pattern. Up 1, right 1. Up 1, right 1. Up 1, right 1. If we want to continue the pattern to the left here, you should be able to see that instead of going up and right, we can go down and left and still get that same pattern there. So if you can make a couple points to the right, couple points to the left, draw a line through them with some arrows. Okay. There's the graph of the linear equation y equals x. Down here we have two special examples, and we talked about them a little bit when we talked about slope, and we've also graphed lines like this before, but let's go ahead and talk through them here anyways. So we have the equation y equals y equals -1, and we want to identify the slope and the y-intercept, or b. Sorry, I'll write that as b just so we get used to seeing it. B is our y-intercept. So notice here there is no x in our equation. That means there's no number attached to x. So when that's the case, when it's just y equals a number, our slope is going to be 0. Okay. Our y-intercept then comes from this number. So our y-intercept here is going to be -1. Now if you think back to slope, or if you think back to graphing an equation like this, what we did in that first section with an xy table, any line that has a slope of 0 is going to be a horizontal line. So to graph this equation, we're going to graph our y-intercept first. It's -1, and then we just graph a horizontal line going right through that point. So when you see a special equation like this, graph the y-intercept and then a horizontal line right through that point. Okay, this is one that I really think you need to memorize instead of relying on the rise, run, intercept. As soon as you see this y equals -1, you should be thinking horizontal line that crosses the y-intercept at -1. Okay. Number 12, last example here, we have the equation x equals 3. Now, if you think back to when we graphed this, or when we talked about slope, anytime we had the equation x equals a number, okay, that was a vertical line. So y equals a number is horizontal, x equals a number is a vertical line. So for a vertical line, our slope is undefined. So the slope of this line is undefined because it goes straight up and down. Okay, and our y-intercept, well, there's not going to be a y-intercept. Sorry, that should be our b. Our b, or y-intercept, we can just say none. Okay. This is another linear equation, special case that you need to memorize. So to graph the equation x equals 3, that is a vertical line that crosses the x-axis. So I'll write that here. Vertical line that crosses the x-axis, not the y-axis now, the x-axis at x equals 3. So if we go to our x-axis and find x equals 3 right there, okay, we plot that point and we just draw a vertical line through it. So we don't have to worry about rise over run. We don't have to worry about a y-intercept in this case. We are just drawing a vertical line that passes through the x-axis in this case at x equals 3. So once again, this is a skill that takes a little bit of time to pick up. However, the more you practice it, the more you begin to pick it up, the more time it will really save you when you are graphing these linear equations.